Hey guys, it's Mr. Regan. Today we're going to look at properties of exponents. First property is the product of powers property. So if we have x to the m power times x to the n power, that's going to equal x to the m plus n power. Essentially, when you're multiplying two factors and the base is the same, you're going to add the exponents. So let's look at an example. Y to the fifth power times y to the third power times y. So if I'm multiplying, each factor has the same base of y. I'm going to add our exponents. So we have an exponent of 5, exponent of 3, and then there's no exponent there, but we know that when there's not an exponent showing, it's always to the first power. So 5 plus 3 plus 1 is 9, and we get y to the ninth power. Now let's look at another one. Let's do 2 to the second power times 2 to the fourth power. All right, so same base of 2. Exponents are 2 and 4. We're going to add those exponents. 2 plus 4 is 6. Now you have to be careful, because sometimes the directions will say simplify with exponents in your answer, and then you can just stop right there, 2 to the sixth power. Or sometimes they want you to simplify it fully, and then you would actually do 2 to the sixth power and get 64. All right, the next property, power of a power property. So now we have x to the m power raised to the n power. This time we're going to take x and keep it as our base, and we're multiplying the two exponents. So when you're raising a power to another power, you multiply. Let's look at an example for this one. Let's do y to the fourth power raised to the seventh power. So we're going to have y as our base. Fourth power raised to the seventh power, we're multiplying 4 and 7, and we get 28. Alright, let's try 2 to the third power raised to the second power. So now we're going to have our 2, and then third power to the second power, we're multiplying, not adding, multiplying. 3 times 2 is 6. And then our answer could be 2 to the sixth power if we were asked to leave our answer with exponents, or 64 if we wanted to simplify it fully. Our last property is the power of a product property. So this time we have a product inside the parentheses, x times y, raised to a power m. When I do that, I can separate the two variables that were being multiplied, x and y, and then they get both raised to the m power, and I multiply both of those. So an example of that would be, in parentheses, a times b raised to the fourth power. So that would be a to the fourth power and b to the fourth power. And there you go. Let's try another. Let's do, in parentheses, 3x to the third power. So 3 is going to go to the third power times x to the third power. And notice I didn't put a dot right there or right there like you see in the example. You can put a dot there, but you don't have to. We know that when you have variables and numbers next to each other like that, we're talking about multiplication. All right, now, this answer might be fine if they wanted you to leave with exponents, but usually they would want you to simplify this more. 3 to the third power is 27, and then x to the third just stays the same, and you would get 27x to the third. Right now we have problems where they combine the properties together. So let's look at something like this. 3x raised to the fourth power times x squared raised to the third power. So now we're going to have a combination of the three properties working here. So I'm going to start off right here. We have our power of product property, because there's a product inside the parentheses, and it's being raised to the fourth power. So we have 3 to the fourth power times x to the fourth power. Then we can, actually, why don't we do this? 3 to the fourth power is 81. Now we'll go over here to the x squared to the third power. So now we have a power of a power property. So x is the base, second power to the third power. 2 times 3 is 6. And now I have this times this. So this goes back to our product of powers property. 81 times, be a 1 in front of there, 1. And then x to the fourth times x to the sixth. X is our base, and when we're multiplying, we add the exponents. 4 plus 6 is 10. And then that would be our answer. 81 x to the 10th power. Let's look at another one of those, because they can get a little complicated. 2y squared raised to the fourth power times 3y to the fifth power. We'll raise that to the second power. Alright, so what I'm going to deal with here, we have our power of products property, because there's a product inside the parentheses being raised to a power. So we have 2 to the fourth, and then we have times y squared raised to the fourth. Then we have the same thing over here. We have 3 to the second power times y to the fifth to the second power. Alright, so my 2 to the fourth power, let's just simplify that to 16. Now I have a power to a power, y squared to the fourth. So we have y to the 2 times 4 is 8, 8th power. 3 squared, we'll simplify that to 9. Once again, power to a power. So y to the fifth squared, 5 times 2 is 10. And now we have two factors. We can multiply this times this. 16 times 9 is 144. Y to the 8th times y to the 10th, product of powers. So we have our base of y. We add the exponents, because we multiply, we add exponents. 8 plus 10 is 18. And then 144, y to the 18th power. Alright, so that's our properties of exponents. We have 3 different properties. Each can do problems individually, or we have where we can combine all 3 of the properties together. Alright, good luck, guys.